Hello guys, hope you're all doing fine today. We're going to be looking at this ocean race 2022-23. This is how the legs look like on the flat earth map. This is the new restored glissons map, restored by Dimitri. And we're going to be looking at all these legs and examining them. That's the first part from Alicante to Cape Town. And then from Cape Town, they're going to go all the way to Itajaí, Brazil. And that's the one that we will be concentrated on today. All the other legs are not really important. So I've been doing some research on this matter, and I'm going to present it today, what I think the situation could be here. So I based the speed of this boat on a race back in 2012 from Alicante to Cape Town. And then with that speed, I used to calculate the trajectory and the speed from Cape Town to Itajaí, Brazil. Let me show what I have found. This is how the race trajectory looks like on the Mercator's projection. Again, we will only concentrate on the leg 3 from Cape Town, South Africa to Itajaí, Brazil. The whole trajectory is supposed to be 32,000 nautical miles, about 60,000 kilometers. Leg 3 between Cape Town and Itajaí, Brazil, we were given the numbers of 12,750 nautical miles. That's the distance according to the organizers, and according to the globe model, that would be the distance between Cape Town and Itajaí. And according to the organizers, it's going to take 34 days for them to conclude this leg 3. As I said in the beginning, I will calculate the speed based on the leg number 1 done in 2012 between Alicante and Cape Town. They were able to navigate 548 nautical miles over one 24-hour period on an average of 22.8 knots per hour. Just to make things a little bit easier, 548 nautical miles equals to 630 statute miles in a 24-hour period. Leg 3, 12,750 nautical miles, converted turns into 14,442 statute miles. At the speed of 22.8 knots a day, they would cover this distance in 23 days, but they were given 34 days. Why? 22.8 knots per hour is not the highest speed. Speeds of 28 knots per hour have been reached in past races. This is the ocean currents according to the flat earth map and also according to the globe. Calculating the speed of these ocean currents is not easy. The main current in the Southern Ocean is the Antarctic circumpolar current, ACC. The ACC is the biggest current in the world and can transport up to 150 billion liters per second of water and reach speeds in narrow channels of up to 1 meter per second. But how do we calculate the speed of the currents? In this National Ocean Service webpage, says that to measure currents, you need 3 basic tools: an observer, a floating object, or a drifter, and a timing device. An observer stands on a ship, throws the drifter into the water, and then measures the time that it takes that object to move along the side of a ship. As technology improved over time, oceanographers began using mechanical current meters. A ship would deploy a meter, and usually some sort of rotor would turn and measure the currents. This is still the basic process today. However, there are more accurate and sophisticated instruments. this current around the Antarctica is the biggest and the fastest one, as this professor explains.
So I've mentioned several times that the Southern Ocean is special because it has no zonal boundaries. It's a complete channel. Since the Southern Ocean is a channel, winds can keep on churning it. So the main features here are the Antarctic circumpolar current, one of the more famous currents. It's also known as the west wind drift, and it's the only current to completely go around the Earth because of the special channel configuration of this ocean. And this obviously moves more water in terms of sphere ribs, the transport, than any other current in the world, right? So look at this figure carefully. It is showing multiple convergences and divergences here. So you have the Antarctic circumpolar current outside, or the west wind drift.
As a matter of fact, in this National Geographic website, they call the ocean currents as ocean conveyor belt. They are similar to the jet streams. Once you are flying with the jet stream or sailing along this oceanic conveyor belt, you have no friction because you are moving forward with the current and not against it. So to better explain, let's imagine a person standing on a conveyor belt, walking conveyor belt, found in airports all over the world. So as you observe this person, he is just standing on the conveyor belt, and in 28 seconds, let's see how many people will go by in front of the screen if the person only stands on the conveyor belt. On example number 2, we will see this person walking, and you can see how much faster he moves from left to right. And in this example, we're going to see a person going the opposite side. As you can see, he remains on the same spot, no matter how hard he tries to go against the flow. So that's why they always organize this race going from west to east, because they will go with the flow. They're going to go with the ocean currents, especially this Antarctic current, which is one of the biggest and fastest one, and that's the way they will be going from west to east. As someone posted a comment on a past video, which says, here is their version of the race displayed on a Mercator's projection. From beginning of leg 2 to the beginning of leg 4 is almost 2 months. They are supposed to arrive in Brazil on April 1st after departing Cape Town on February 26-27. But then it will take them almost 4 weeks to start leg 4, while in most legs that get just about 1 week break in between. I don't think they will complete the leg South Africa to Brazil in 34 days, and then take a 4 weeks break before going to Newport. We have already seen that these ocean currents are called ocean conveyor belt, which means they move from one direction to the other, and anyone who gets on these conveyor belts benefit adding the speed of the current with the speed of the boat. There will be 60 days between start of leg 3 to the start of leg 4, even though they claim that the race itself from South Africa to Brazil will take only 34 days. Let's imagine that they are doing 28 knots per hour, which means 32 miles per hour. So you multiply 32 miles per hour for 24 hours, they would cover 773 miles a day. 773 miles a day for 34 days equals to 26,282 miles. That's calculating that they can reach the speed of 28 knots. But we don't know how fast those currents are around the Antarctic Circle. Let's calculate if they reach the speed of 35 knots per hour or 40 miles per hour. 40 miles per hour times 24 equals 966 miles a day. 966 miles a day for 34 days equals to 32,860 miles. Remember, there is no friction because they are going with the currents, not against it. Not knowing exactly the speed the southern currents can reach makes it difficult to know how fast these boats are going along the currents. Very similar to what happens to the jet streams around the edge of the flat Earth. Those winds can reach speed of up to 300 miles per hour. And remember, there is never a friction because they are not flying, or in this case, sailing against the currents. That's why they're going from west to east. They are moving along with the currents, adding to the speed of the boat. One thing we know for sure, if the Earth was a ball, it wouldn't take them 34 days to complete this leg. It would take them the most 23 days. But they have 60 days between the beginning of leg 3 from South Africa to Brazil to the beginning of leg 4 from Brazil to Newport. So it might take them 34 days, 37 days, 40 days, we don't know. At this point, the only thing I can tell you is that if we were on a ball, it would not take them 34 days to go from South Africa to Brazil. It would take them the most 23 days. That's all for today, guys. Thank you so much. See you next time. Bye-bye.